Good morning, everyone. It is Monday morning and it is freezing out there. I'm going to read you part of a book, only part of it because it's so long, but it is called Powerful Waves. The author is D.M. Souza. And I'm reading this because I was walking this weekend and the ocean was crazy, and I thought maybe you guys saw it and you'd like to hear a little bit more about waves. So we're going to read from Powerful Waves. If you've ever walked along an ocean beach, you know how restless the sea is. Waves break against the shore, leave treasures from the deep, then slip back into the sea again. Sometimes the waves are gentle, other times they foam and churn, tossing ocean ships about like little boats, little toy boats. One kind of wave, however, is more powerful than all others. It can tear apart homes, steel bridges, and concrete buildings. It can uproot trees, twist power lines, and sweep city blocks clean of everything. This wave is a tsunami. Tsunami is a Japanese word meaning large waves in the harbor. The word can mean a single wave or a series of waves. The Japanese people know the force of these waves well. They have seen thousands of people, their homes, and their belongings washed away by tsunamis. Some people call these mighty waves tidal waves, but as you will see, tsunamis have little to do with the tides. What are waves? In the sea, waves are up and down movements of water. Small waves, called ripples, only lift the water inches above the surface. Other waves, like storm waves, may raise water over the decks of ships. The highest point of a wave is its crest. Between the crests of two waves is a low valley called a trough. The height of a wave is the distance from the trough up to the crest. Scientists can tell how long a wave is by measuring how far one crest is from the next. Inches may separate the crests of ripples. The length of several football fields may separate the crests of larger waves. Waves usually follow one another, forming a train of waves. In the ocean, many trains are moving in different directions at the same time. Some crisscross one another. Their waves may run together and grow bigger, or the trains may break apart, making the waves disappear. The time it takes two crests in a train to pass the same point is known as a wave period. Scientists use wave periods to figure how fast waves are moving. Most waves at sea have periods of 2 to 20 seconds. This means the waves are traveling from 7 to 70 miles per hour. The average speed of an ocean wave is about 35 miles per hour. In deep water, when you watch waves far out at sea, you may think the water is moving along with the waves, but it isn't. Your eyes are playing tricks on you. Try tying a rope to a doorknob and snapping the rope several times. Notice how it lifts and falls in wave-like motions. The waves move along the rope, but the rope does not move forward. This is what happens with water waves. Imagine water lying under the snapping rope. With each up and down movement of the rope, the water also moves up and down. It rises to a crest, turns a somersault into a trough, and then returns to about the same spot it was when it began. Beneath the first large somersault, the water turns in smaller somersaults, one beneath the other. Each turn is deeper and smaller. Near shore. As a wave train gets closer to shore, things change. The ocean gets shallower. Water below the waves has less and less room to turn in somersaults. Some somersaults strike the ocean bottom and drag. Then the water simply moves back and forth in a straight line. The water at the top, though, continues to somersault. It turns over faster than the water below. The crests begin to crowd together. They build higher and higher until they become top-heavy. Finally, they tumble over. A foaming mass of water rushes toward the shore, races onto the beach, then slips back out into the sea. How do most waves form? Waves are usually formed by the movements of the tides and the winds. Tides are the work of the moon and the sun. The moon and the sun pull on the earth like a magnet. This pulling raises the level of the earth's water in some places and lowers it in others. Twice each day, water comes further up onto the shore than normal. This is called high tide. At low tide, the water is pulled away from the shore and moves farther back into the sea. If a storm arrives during a high tide, waves on shore will be stronger and higher. High tides can bring dangerous floods sweeping inland. Most waves in oceans and lakes are caused by wind. A slight breeze blows across calm water and ripples appear. If the wind picks up speed and strength, the ripples become bigger waves. Winds blowing at 30 miles per hour can lift the sides of waves to about 15 feet. Strong wind-driven waves rise to an average height of 40 to 50 feet. Hurricane winds can whip up even stronger superwaves that may sweep away buildings, animals, cars, trees, and power lines. Some people think these large storm waves are tsunamis. They are not. And if you would like to find out more about tsunamis, you can check this book out from our library. A Parent Square message went out probably around the middle of October, showing you guys, there's a video that shows you guys how to put a hold on a book and explains how to check out a book from our library. So if you're interested in finishing this book, you can check it out from our library. All right, guys, I hope you have a great day. Bye.